by head gestures and movements, and we can make some pretty cool stuff. Sometimes. See? I told you. We can make it do some pretty cool stuff. So, what you got to do is you have to have it in your line of sight. And it's really hard to fly it indoors because it's really made to fly outdoors. So I'll give it one more try. So, see if we can make it fly in. Whoa. So, I just want to put it. So those are the couple things we can do with it indoors, and some of the things now. Glass totally controls it. Nothing else is used. It's an application we designed and built right here on the platform, and using the Wi-Fi and streaming data. Also in my glass, as I'm looking at it, I actually see the camera. The HD camera is feeding live into the glass, and I can see what the drone's seeing. So at 180 feet, you can see everything in panoramic view. Also, it has a camera underneath, and you can see the camera underneath also. And you can see all the telemetry and everything else. After tonight, if somebody wants to take a look at how it works, and fly it, but you can see all the telemetry, what I'm seeing, be glad to show some demos for it. So after that, it's on to you, Eric. Thank you for coming. My name is Dave Martinez, and I'm with Brick Simple.
How's everyone doing?
Remember, Dirty Dave.
Who's ready for an exciting show tonight?
Whoa.
So, how many of you guys are Bay Area Mobile UX Meetup members? Wow. Okay, good. Good turnout. Good turnout. I see a lot of familiar faces. So I run 3 meetup groups: UX Leadership, Pretty Mobile, and UX Bay Area Mobile UX UI. And it's great to see many of you guys here. How many of you guys signed up through Eventbrite? Okay, cool. Good turnout. So yeah, so I like to run these monthly talks, maybe once a month, about mobile UX, UI related, wearable, Internet of Things. That's kind of the next thing that we're going to talk about. A lot of you guys have these flyers. So I'm a UX UI designer, and then as well I teach at UC Santa Cruz Extension in Santa Clara at Silicon Valley. So I'm teaching a 6-week workshop on how to design mobile applications for iOS, Android KitKat, Windows 8.1. We're going to dabble into Google Glass. I'm going to teach you the whole methodology about how to design an interactive prototype. So if you guys are interested in learning how to design a prototype in 6 weeks, let me know. And yeah, this is going to be an exciting event. And I think we're ready for our next speaker. So our next,
So big round of applause for Manuel Novello. Yeah. Come on, let's hear it to my friend here, you know? You're getting a $600 ticket. Anybody get that? $600. So for that, we ought to be clapping and throwing money up here. All right? I'll get you a bucket. All right, Manuel.
Thank you. Thank you very much, Dave. Hey, everybody. How's everybody? Good? Great Friday, right? Okay, let's start. I'm going to be talking about the evolution of technology, and the name of my talk is Let Technology Evolve. So let's see. I want to ask you, who remembers this little toy called the 3D ViewMaster? Please raise your hands. Yeah, everybody remembers that one, right? That's fantastic. Everybody used it when you were a kid. You know, it was fantastic and amazing to use that. Well, that's exactly how everything started for me. I'm going to tell you my story really quick. You can picture me.
Keep it down in the back.
You can picture me back in Mexico, 1979. I was 9 years old. And it was interesting. My grandparents gave me this toy as a present. And I had this ViewMaster, and they gave me this flipper reel, which was very real. Like, it was like the flipper was just jumping in front of me in the water, and the whole, depth was right there. At the same time, they were broadcasting the flipper television series on television. And I used to look at Flipper on the television, and I was like, well, why is it that Flipper looks so different in the television than in the 3D ViewMaster? So I asked my parents. And they said, well, it's interesting. It says here in the brochure that you have like a 3-dimensional view, and it's a left and a right images. So that's why you have like a 3D view, and TV is not 3D, it's 2D. So it was interesting. I started playing with computers, Apple IIe, 1983, then 1986 with computers like PC and AT and all that. Kind of a geek at my age of 13 and 15. So what I did is that after Bachelor of Science degree on electronics engineering and a couple of companies after, I was with my wife and I asked her, hey, you know what? All this time has passed since I was a kid. Nobody has come up with the idea of having a three-dimensional television at home or 3D at home. Why is that? I'm sure it's doable. I mean, I know electronics engineering. I've been programming forever. I know it's doable. And she was very supportive. And I told her, well, if I'm going to make this, I want this to be digital. Back in 2001, everything was analog. You know, it was not even a requirement to have high-definition channels. So I said, well, it has to be digital so we can keep the best image that we can. High resolution, high definition. It also has to be compatible. I didn't want it to have a 3D that was, you know, breaking the continuity between 2D and the next generation of television. Kind of like what happened from black and white to color. They were compatible. Can you imagine if they were not compatible? Well, that would be like a big problem to create new content. So I was like, it has to be compatible. And at the same time, I wanted to be performing just like the human eye, that your eyes and my eyes work. Every time we look at something, it converges, and we're constantly changing our angle of convergence based on the object of interest. So I said, well, those are my prime directives. That's exactly what I am going to design. That's what I'm going to do, and I'm going to search everything that is out there in the world. So I was, to tell you the truth, I was afraid that, you know, companies like Sony or Panasonic had already done that. So I started searching, you know, with patent attorneys. We got this worldwide search of prior art, and then, surprise, there was absolutely nothing similar to what I was proposing. So I decided to take the step, and I moved forward. A few years later, 2003, I opened the company T-Division in the United States. So there were no three-dimensional cameras. There were no three-dimensional Blu-ray or DVDs. There were no 3D televisions. There were just a few attempts to have 3D with analog CRT monitors. You remember these big old monitors? They were, for all those that are born after the 80s, these things were not always like this, okay? They were like big boxes with a CRT, a cathode ray tube that was behind it. It was a huge television. So I didn't want to use that because they were like, you know, real bulky, and the refresh rate was like 60 hertz, and if you wanted to do 3D, you can see a flicker, and I didn't like it. I just didn't like the experience. And there were also like the red, blue, and anaglyph information. I didn't like it either, because that's not the way we see. So I created my first set of cameras, high-definition cameras. We called it the TDV cam. It was the first high-definition resolution three-dimensional camera in 2003. Then I created the system for encoding the content that was acquired by the camera. And at the same, I also did the decoder, and I needed to show it somewhere, so I created my own head-mounted display. The one that you see over there in the first one. That was kind of the first prototypes. There's my son in 2004 playing with the first prototype. It's interesting because back then, I mean, he was little. Now he's going into university next year. I'm kind of in shock. Anyway, so we started doing that. Created practically the entire chain. And in 2006, when I had a stable version of the prototypes, I started demonstrating this technology all over the world. I created all this pipeline from A to C, and I was demonstrating that. I was showing that. I was promoting that everywhere. It was interesting. People was trying, you know, the head-mounted displays. Back then, we had the first high-definition resolution display, head-mounted display, 1280 by 720 back then. People was very excited about it. And then it was in 2007 and 2008 that I started showing it to companies like Sony, Panasonic, Samsung, Warner Brothers, Disney, everybody. And I was telling them, look, this is what we can do. This is what we can have today in the home. They were kind of slow moving forward. They don't take decisions like, you know, a small company that can take decisions and put them to work and execute. It's more about the big companies have to have all these decision makers, all these departments working together to make something happen. They move really slow. While we were presenting all this technology in different shows, from specific applications like video gaming and simulations for military, all the way to medical or consumer electronics or even broadcast fairs, many companies and many corporations, including Lockheed Martin, Northrop Grumman, NASA, Langley Center, they saw our technology, they liked it, and they were evaluating our platform, and they said, you know what, this is interesting, we like it. And even when it was a prototype, even when it was something that I was just showing and I was not intending to sell, they were acquiring this. I want 20, I want 50, I want 100. We received purchase orders from the military, from the Pentagon, from different universities, the University of Iowa, the University of Chicago, University of California. We started making these telepresence projects. It was not like in a public base because it was not reaching the consumer yet. It was just for medical and specific professional applications. To tell you about my experience, it was complicated. In my view, I was expecting companies like Sony and Panasonic to really pick it up and say, we're going to do it, we're going to support you, and we're going to have 3D to the home. But they were not. I was talking to a couple of friends earlier today, and I told him we were about to close the company probably like 5 times in the meantime, because it required a lot of resources, development, research, you know, the payroll, the operating, everything. It was a lot of cost. We were about to close the company many, many times. And we were like, I don't get it. We have the patents. I submitted the patents to the standards, to the ISO standards, and I told them, hey, you know what? If in the future anybody wants to do 3D, here's the standard. Use it. This is my patent. And I filed what is called the friend and non-discriminatory agreement of licensing, where everybody can use it. You just have to contact us. And I put it there and I said, well, if anybody wants to do 3D, it's right there. There's a patent, there's the know-how of how doing it. Then, something interesting happened. In 2009, December 19th, I'll never forget that date. December 19th, in 2009, the Blu-ray Disc Association pronounced themselves and they announced themselves that they had selected a standard for the 3-dimensional Blu-ray that was going to be inside every single 3D Blu-ray player in the world. And they selected our standard, our patent. So that was fantastic for us. I think we're still celebrating as of today. I mean, it was amazing for everybody. We were for so long waiting for this, and it happened. So it was very interesting for us. You started to see all these Blu-ray players, the Blu-ray movies. One of the first movies that we had encoded was Polar Express from Warner Brothers. It was amazing to see all these computer-generated graphics in front of you, like if they were there, like if it was real. I was so, excited about it. The whole thing was becoming a reality. PlayStation started to push the firmware updates. One of the things that changed, it was just interesting. I had this head-mounted display, and I decided that I had to stop that development because there was no content. So if there were 3-dimensional displays out there that say you can push like 5 million devices tomorrow, what will they see? There's nothing, there's no content. So I said, well, let's work on the content, let's work on the platform, and then we go for the head-mounted displays. It was interesting to see the evolution from a Viewmaster toy all the way to a device that allowed you to see images in 3D as if you were there, as if they were there, moving images. Like more than video, it's not video, it's just like looking at something that is happening in front of you, but it's not. And all this evolved around the world. We were not the only company. You probably saw all these other companies like Vuzix, MyView, Imagine. Some of you probably remember all of them. You probably have them all in your shelves. So we tried them all. We used them all. It was interesting. There were many companies working on that, so that means evolution was happening all around the world. It was not one company. It was not 2 companies. It was like a general global advancement. Simultaneously, going from the augmented reality heads-up display from the jet fighters back in the 60s, 70s, and 80s, where they had these little green lines showing you, the angle on the horizon and speed and some other stuff. It evolved and it went to the consumer electronics market. And now it started to come into the way of applications, apps that you can have in your phone. Right now you can download them for free to see and augment the reality and see some metadata, information, graphics that do not exist in reality. But you can bring them on. And it all evolves. It evolved everywhere. Around the world, many sensors, new devices, new displays, heads-up displays, they started to appear everywhere. So there you go. Augmented reality also evolved. And the same happened with robots and drones. Dave just shows what he can do with his glass, his Google Glass, and he can control the drone remotely. He can see what's happening in the other side of the camera of that drone. Robots have evolved. Asim was one of the examples. The robot that is now in NASA, they have one in the International Space Station. So all this technology has also evolved at a very interesting pace. Of course, the Moore's law has helped to happen, right? Because now we have a lot of processing power and mechanics and working. But there are many challenges. There are so many challenges around the systems that need to be solved. And I believe that pretty much all the people that is here is going to help to solve those challenges, including from infrastructure, architecture. I've been there, I've done that. It was complicated to get the 3D Blu-ray to the world. Now you're going to need some infrastructure. You're going to have an infrastructure that is going to use, augmented reality, virtual reality, content of every kind. Gesture interfaces, standardization of the protocols. Right now, everybody's doing their own augmented reality platforms. They don't talk to each other. You're not going to end up with pre-replicated different types of databases with metadata. We need to standardize that. We need to be able to capture information here with one application, and then immediately on the other side of the world, they already have that information, independently of the platform, independently of the system that they're using. Many things need to happen. All that information that is around there in the internet is scattered. It's all around the place. There's no way today to intelligently get all that information and put it together in a way that makes sense. So much information. Even Google is trying to work on that. Facebook is trying to data mining all the information with artificial intelligence databases and stuff. So it's getting very interesting. Where does science begins and where does fiction ends? And when you think about it, all the things that we have seen as fiction are now a reality. And it's going to keep happening. That's part of evolution. When you put all these things together, the way our augmented reality evolved, virtual reality evolved, robotics evolved, artificial intelligence evolved. The interesting thing is it's a collective evolution. Everybody from different parts of the world with different cultures, they are learning, they are looking at the same future, and they are developing new initiatives. And they all coincide. We're looking at the same point all around the world. And we have to make it happen. And the only way to make it happen is to have a complete infrastructure that is seamless, that is standardized. So where is all this going? You have AR, VR, augmented reality, virtual reality, artificial intelligence, and robotics. Where's all this going? Where's this going to take us? Well, this is the interesting part. It's going to take us to new worlds that do not exist. People is going to create like an alternate parallel universe where you can see things that do not exist in front of you with augmented reality, where you can jump inside a virtual environment and think and do things and work and play and see people that are not in front of you, but you will swear that are there. The reality, the quality, the renders, and all that processing power applied is going to create an alternate universe where we can all jump in or augment reality. And we need to base that into artificial intelligence. That's the next step. And that's happening. And that's Eileen. You will see it later. So with this, I leave you to the message of letting technology